Okay, we'll continue with the problems. Solve the recurrence relation an minus 3an minus 1 minus 4an minus 2 is equal to 4 raised to n. Solution. Given recurrence relation is non-homogeneous because we have 4 raised to n. So whenever you have a function in n, together with this relation, whenever you have a function in n, we call it as a non-homogeneous. So this is non-homogeneous. Characteristic equation is, so this is second order equation. Let us find the order. So here order is given by n minus highest term an, least term an minus 1. So we subtract n minus 2, that is n minus n plus 2, we get 2 here. So what about the order? Order is 2. So whenever order is 2, we have to write the characteristic equation starting with square. Since order is 2, r square, r, then constant term. We can take the coefficient 1 r square, then here it is minus 3, right? Minus 3 r, then the next coefficient is minus 4, that is a constant term, and is equal to 0. So while writing the characteristic equation, we have to consider the order of the equation. Here it is r square. We take the coefficient of an is 1, coefficient of an minus 1, minus 3, an minus 2, minus 4. So 1, minus 3, minus 4. Then r square, in the decreasing power we take this. R square, r, then r power. This is r power 1, right? Then r power 0 is 1. That is 4 itself. Here you don't take 4 power n. We have to take 0 while writing the characteristic equation. So you can use your calculator, students, not just like factorization. It is very simple. You can use your calculator and find the roots 4 minus 1. Now they are distinct roots. By the rule, the homogeneous solution is alpha 1 minus 1 power n plus alpha 2 4 power n. Okay, since they are real and distinct. Now to find the particular solution, f of n is, from the question, f of n is 4 power n, and 4 power n, f of n is of the form a raised to n, and a is a simple root. Why do we call a as a simple root? What is a in this case? 4 raised to n is the RHS here, okay, that is f of n, and 4 raised to n is of the form a raised to n, and that means a is 4. A is 4. Whether 4 is a root of the characteristic equation, that's what we have to verify. Yes, 4 is here. Since the roots are 4 comma minus 1, 4 is a root. There is no repetition of 4. Therefore, we call it as simple root. Earlier I explained this. If 4 is repeated 2 times, suppose the root is 4 comma 4, you will call it as double root. If you get 3 times 4, then it is triple root. If there is no 4, suppose while finding the roots of the characteristic equation, there is no 4, sometimes it is 2 comma minus 1 or something like that, then we say 4 is not a root of the equation. But here 4 is there and it occur only one time, so we call it as a simple root. Okay. So what is an when it is a simple root? When 4 is a simple root, what is an? An particular is cn 4 power n. So we learned this earlier. Okay, we learned what about that? We know the value is, so this is the table we learned, right? If it is f of n, if f of n is of the form, if f of n is of the form a power n and a is a simple root, that means it is repeated, no repetition, only one time it occurs. So 4 occurs only one time. So what is the form of an we have to take? An is cn a raised to n. Okay. If it is double root, cn square a power n, cn cube a power n, triple, not a root means c a power n. So here it is a simple root. That means only one time it occurs. So cn a power n. Okay. Now an is cn. You see it is here cn a raised to n. What is a? A is 4. Okay. A is the root, that is 4 here. So cn 4 power n. So an particular solution is cn 4 power n. Now we know n minus 1 is replace n by n minus 1. Here also replace n by n minus 1. So n minus 1 is cn minus 1 4 power n minus 1. What is n minus 2? C replace n by n minus 2. Cn minus 2 4 power n minus 2. So now let us take the given equation. This is the given equation, and here let us substitute an minus 1, an minus 2 values. Okay, we have to take 4 power n also. So we get, okay, considering the given equation, this is the given equation, and we substitute an as cn 4 power n, then an minus 1 as cn minus 1 4 n minus 1 it is here, an minus 2 as cn minus 2 4 n minus 2 is equal to 4 raised to n. Now dividing by 4 power n minus 2. Why do we divide by 4 power n minus 2? We have to find the constant c. So to find the constant c, we divide by the least power, okay, 4 power n minus 2. So dividing each and every term. So first term by 4 power n minus 2, second term, then this is the third term by 4 n minus 2. RHS also we divide by 4 power n minus 2. So after this, what we can do? We can eliminate the terms here. You see, we can cancel 4 power n and 4 power n minus 2. Similarly, we can cancel 4 power n minus 1 by 4 power n minus 2. Here this 4 power n minus 2 and 4 power n minus 2 will be cancelled. Here also we can eliminate 4 power n by 4 power n minus 2. So it will be like this. So let me explain how to eliminate. So 4 power n by, so this is 4 power n and this 4 power n will be, so let me write that again. 4 power n by, this can be splitted as 4 power n, 4 power minus 2. Here this can be splitted 4 power n minus 1. So this is 4 power n minus 1 minus 1, right? 4 power n minus 2. Here 4 power, so this can be eliminated. So we can eliminate this term. Here also this will be eliminated. Here this 4 power n minus 1 will be there. So let me, here there is 1, this becomes 1, and this one 4 power n by 4 power n into 4 power minus 2. So we know a raised to x plus y is a power x, a power y, or some number 2 a power yes x plus y means you can split this a power x into a power y. So we can split this 4 power n minus 2 as 4 power n into 4 power minus 2. So now what happens? This will be eliminated. Then here, okay, we have 4 square. Here this 4 power n minus 1, 4 power n minus 1 will be eliminated. We have 4 power minus 1. Take this to the numerator, 4. Here it is 1. Take this to the numerator, 4 square. So actually I have taken only the coefficients. Okay, so if you look here, this 4 power n and 4 power n minus 2. 4 power n will be eliminated. 4 power minus 2, it goes to the numerator. This 4 power n minus 1 will be eliminated. 4 power minus 1 will be there. That's what I explained here. Okay. This 4 power n minus 2 can be splitted as 4 power n minus 1 minus 1. So you have 4 power minus 1 in the denominator. Okay. After cancelling you have only, okay, this is equal to 1 by 4 power minus 1. So you can take this to the numerator so that you get the next step, that is 4. 4 power minus 1, when it goes to the numerator it becomes 4. Here also 4, this is 1 by 4 power minus 2. When 4 power minus 2 goes to the numerator it is 4 square. So here it is 1 because eliminating. Here 4 power n will be, so this is 1 by 4 power minus 2. When it goes to the numerator it is 4 square. So what happens? Here it is 4 square. Here it is 4. Here it is 1. So this will be eliminated. You have 4c n minus 2. This will be eliminated. Here you have 4 square. Okay. So this terms 4. You can take 4 square, 4, 1, 4 square. So here you see 4 square, 4, 1, 4 square. So now expanding this, we get 16, 3 4s are 12, and then here no change, 4 square 16. So expansion you can do it on your own. First term no change, second term expand it, 12cn plus 12c, here also minus 4cn plus 8c is equal to 16. Then 16cn, So adding, you see minus 12cn minus 4cn is minus 16cn, 12c plus 8c, it is here, then here it is 16. Now this 16 and minus 16 will be eliminated. You get 20c is equal to 16, c is 16 by 20, c is 4 by 5. So a and p. So why do we do all this? To find c. So after finding c, we can substitute it in the solution. So this is our particular solution. General form, right? When a is a simple root and it is of the form 4 power n. A particular, this is the particular, you can put this inside a box, okay? This is the particular solution. We have to find c. That's why we took an minus 1, an minus 2. Now we got c. Substitute it in this particular solution. So cn 4 power n. So we get cn, c is 4 by 5. 4 by 5 n 4 power n. So now general solution is given by, what is the general solution? Homogeneous solution plus particular solution. So already we have the homogeneous solution, that is alpha 1 minus 1 power n plus alpha 2 4 power n, and particular solution is here. We can add it together with this 4 by 5 into n 4 power n. So this gives the solution of the non-homogeneous recurrence relation. So all that you have to do is find the homogeneous solution first. Then you identify f of n. F of n is a constant, or it is of the form a raised to n or t power n. Identify the constant, and accordingly you choose an, okay? Accordingly you have to choose the particular solution, and using that particular solution you have to find c value, and so that you get the particular solution. After substituting c value, you can write the particular solution. Then finally general solution is sum of homogeneous and non-homogeneous solution. So this gives the final answer or solution of the non-homogeneous recurrence relation.